Hello and welcome to the video. This is a little video talking about how you can convert a board that's designed for a quadcopter to be used in something like a wing or a small airplane. Now this is something that I've been asked for a little while, and particularly by a Patreon called Sarah. So Sarah, this one is for you. There are two other series that you may have seen on the channel already. One is around how I did this a long time ago using an Omnibus board, quite cheap and cheerful. And then the second one up here was where I did it with a Matek F405 wing board. Both of those are supported in Ardupilot. Now, I've done lots of series with Ardupilot on Pixhawk style boards, and the Pixhawk stuff offers a number of advantages over some of the non-Pixhawk stuff, particularly things like sensor redundancy, vibration isolation, temperature management of things like the IMU, CAN bus support. Some of those stuff are starting to appear in the more expensive flight controllers, but I know what a lot of you are after are, can I use my 30-40 pounds new flight controller, or maybe one I've had in the spares bin for ages, and stick it in my wing to try something like Arduplane. Now, another thing that's quite commonly talked about is, well, should I use Arduplane or iNav? I have a video about that, again, link below, but that is really down to whether or not you're coming from a Betaflight background to iNav, or whether or not you want super silky mission-based flying and the ability to do VTOL. That will kind of dictate which you're going to use. I'm a big fan of Arduplane, particularly with all the building I've been doing recently. So I'll put links to all that stuff down below. In this video, what we're going to do is we're going to take one of the new HolyBro Kakute H7 V2 flight controllers designed to be plugged into a 4-in-1, and we're going to modify it to make it so that it's ready to fit into a wing. Once the small bits of modification are done, and it's not really modification, you don't have to do it this way, there are other ways as well, then the setup of the board, plugging in the external GPS and compass, the receiver, those kind of things is exactly the same as every other single Ardupilot video series that I've done on the channel. So this is the only bit of difference that there is. And there's only really 4 things that you need to figure out for the board that you have in your hand to figure out whether or not this is possible with the board that you've got. Because although I'll show you with this HolyBro Kakute board, it'll work with any board so long as you can tick these 4 boxes. First box is the flight controller supported by Ardupilot? Not particularly tricky to find out. There's a whole list on the Ardupilot website with the supported closed source, I think they're called, rather weird name, on the Ardupilot docs. Again, link below to have a look at that. A lot of the manufacturers these days also include the name of the target in the listing for the boards. HolyBro did it with this Kakute, which made it an awful lot easier. Second thing you're going to have to be able to do is to figure out how to power the board. With a lot of the boards designed specifically for wings, like the Matek boards, they have pads that you connect the battery terminals to. So it's powered directly from the battery, and then there's usually output pads to the ESCs. With boards like this, they're really designed for a quadcopter. They don't have those. However, lots of modern flight controllers will take the full battery voltage and then convert that on board for the 5 and 3.3 volts and things it needs for the logic that's actually on the board itself. So you can just plug it onto the pads that have full battery voltage, whether that's the XT60 or something like when it goes onto the ESC. The other thing that we need to figure out as well is how do we then convert the outputs that typically would be connected to the ESCs on a quadcopter or octocopter or whatever it is that you would use this board for, to be something that you can plug servos and ESCs in inside a fixed wing. I have one particular way of doing that, and that is to actually make a little external adapter using a little row of 3 servo pins, the kind of thing that you would get that you'd normally solder onto a flight controller. I make an adapter. You could directly solder things like servos and stuff onto the flight controller, but I find this a great way, because it gives me a way to power the servos from the 5 volts coming from the speed controller, and without having to use any of the power system that's already on the flight controller. Because these kind of little flight controllers kind of don't expect to be running servos that are going to be pulling, you know, the thick end of an amp when they're really working hard, and you might have 4 or 5 of those on a model. Last thing to think about is because this is Ardupilot, you are going to need to plug in an external compass and an external GPS. So you're going to have at least one spare UART for the compass, and you're going to have the serial clock and the serial data lines, the SCL and SDA pads on the flight controller as well. If you have all of those things, then you're good to go. So let's crack on and let me show you how I've converted this particular flight controller for ready to be put inside a plane and set up. So the first thing we need to do is to flash this board with the firmware that we need. Now, my plan with this, as I said in the introduction, is to use this with Ardupilot inside a plane, which is kind of the whole point of the video. There are a couple of cables here that are going to present the things that we need, and a cable in this particular HolyBro Kakute H7 V2 that's used for the DJI system. So let's just take these off for the moment. We don't need any of these. We will be coming back to them shortly. Now, if I just jump onto the computer, we can have a look and find out whether or not this is supported. Now, all the links I'm going to show you are going to be linked down below. So here is the Kakute H7 V2 page on the HolyBro website. And if we zoom down here, then there's an awful lot of information about how everything works, including how you connect it to the DJI Arcadic system, and it's all laid out really nicely. Even things about how you can turn the power on and off to the HD system, which is probably less useful for the DJI, particularly if you're using it for S Plus control, but for something like walk stale or HD0, that could be very, very handy indeed. Now at the bottom, it says support firmware listed here. If we click on that, it'll come and show you that this not only supports Betaflight and iNav, which you'd kind of expect, it also has an Ardupilot target. It's called Kakute H7 V2. We need to be on Ardupilot 4.3 or newer. There's also a PX4 version, and they've actually got the PX4 versions down here. So we now know that it will support Ardupilot. So that is good news. We know we can actually flash this thing. Now to flash this thing, we're going to use a pretty standard thing that I've shown in lots of other videos. We can't flash it directly from Mission Planner initially. We need to flash it with the bootloader, and then we can kind of play with it afterwards, because typically these kind of boards are shipped with either iNav or Betaflight. So we need to download the file that's going to be flashed on here for the first time, and we're going to use something like iNav or Betaflight Configurator to flash it, and then once it has been flashed, then things get an awful lot easier. It's just that first time moving it across. So the thing we need to do on the computer is we can have a quick look here in the Ardupilot documentation, and here it talks about all of the different setups. It talks about the pinouts, and we'll need these. We'll come back to this in a minute. It talks about exactly where we're going to connect up the conversion to take it from a flight controller really designed for a quadcopter or an octocopter into something more useful for a plane, and with also some extra things here as well. Down here we also have what each pin does, and really importantly, we also have the UART mapping, so we can see exactly for Ardupilot which serial setups correspond to which UARTs, and that's going to make the setup really easy. So we need to download the firmware for it. So what we're going to do is we're going to the Ardupilot firmware.ardupilot.org site. Again, all these links down below, and we're going to look for the one we want. Plane, copter, rover, sub, blimp, believe it or not, and all these different things. We're just going to go, because this is ultimately the idea to put this into a plane. We're going to go into plane. We're going to go into stable. There's all these different versions. This is where you come for all the versions if you want them. However, I wouldn't go for the latest beta test stuff unless that's what you're doing. The latest is normally the very latest and greatest. That could be very new code. I'm going to click on stable, and we're going to go and hit Control F on the keyboard and type in Kakute, because that's going to find the bit we want. If you remember, we're looking for Kakute H7 V2. There it is. And there is the Ardupilot with bl.hex. That's the one that we want. So we're going to download that and put that somewhere safe. So now we've got the file, we can actually flash this thing. So what we're going to do is, before we plug the board in or do anything, we will actually just get ready to flash it. So I've got iNav configurator here. I'm not going to do any of the setup. What I'm going to do is I'm going to go into firmware flasher, And all we're just using this for is simply to get that first firmware on. We're going to load the firmware locally, and I've stuck it on the desktop. There it is. I'm going to say open. And there we go. And then we don't change anything in here, no reboot sequence. We make sure that full chip arrays is set. And then what we're going to do is we're going to plug the board in holding the boot button. On here, it's this little button here. There'll be some kind of DFU button or boot button that you'll have on yours. I'm going to press and hold that as I plug it in. And on the computer, it hopefully, if you have the drivers set up properly, it'll appear here as DFU in the top right hand corner. If it doesn't, I'll put a link down below to my Zadig video. And then we're just going to hit flash firmware, and it's going to gently flash the firmware. First of all, it's going to erase the existing firmware that's on the board. And that's going to take a second, and then it's going to put that hex file that we downloaded with the bootloader onto here so that we can then carry on configuring everything. Again, this is very, very much the standard way of doing it. I've done lots of video series here on YouTube where I've talked about this process, and we've done it with things like Matec flight controllers, with Omnibus flight controllers, all kinds of different things. So once it's done, then this board, we can plug it into Mission Planner and we can do all the standard setup steps. The setup steps and how you configure everything is exactly the same as a Pixhawk or any other of the series on the channel. You're going to go through and do things like calibrate the accelerometer. You're going to do things like calibrate the radio, set up your flight modes, configure the outputs. All that stuff is identical. Just because we're using a little board like this rather than a Pixhawk doesn't mean that anything is different. Now this is going to take a minute to get all the software on here, so I'm just going to skip to the end. Here we are, we've just finished, and you can see the blue light flashing as it reboots. It's now flashed with Ardupilot, and we know it's going to be flashed with Ardupilot because when we look at it in Mission Planner, we should see different COM ports appearing. So let's try that. So here we are in Mission Planner, and we are connected to the flight controller. It's all powered up. What we're going to do is we're going to look, and there hopefully is going to be a USB port. Now there isn't on this one, interestingly, so what we'll do is we will unplug and plug the board back in just to make sure that it boots cleanly. So let's plug that back in again. Give it a couple of seconds just for all the capacitors to completely empty on the flight controller. There we go, that's now firing up. And then hopefully in the drop down list we'll see it. There it is, COM27. Let's click on connect, and hopefully after a moment we should start to see all of the pieces. And as I move the board, we can see here in the top left hand corner it is all moving around. So that is working as Ardupilot. So that's how we can identify the board, download the firmware and get it on there. And it doesn't matter what the board is, as long as it's supported, you follow exactly the same process. So the next job then is to figure out how are we going to power this board, because typically this board is designed to plug it into some kind of 4-in-1 ESC setup, and that typically would supply the power that's going to run the entire board. Now there is usually a 5-volt supply as well as a 3.3-volt supply that's going to run the electronics that are on this flight controller, but we're also going to need a separate 5 volts to power things like servos in a wing or plane. But we'll look at that in a moment. Let's just worry about actually powering this thing for now. Now when I plug it into the computer via the USB cable, it's going to supply the 5 volts that this thing's need. However, something like this will be getting battery voltage from somewhere, and that battery voltage is going to be then managed by some battery eliminator circuits and drop down to the voltages that this thing actually needs to run. Now to figure out where that is, whether it's on the pins or on these inputs or outputs, we need to look on the computer. So here on the computer, we're back on the details for the flight controller on the Ardupilot website. And as we scroll down, we can see that it's powered by a 2S to an 8S LiPo battery. That is fantastic, because that now means Rather than us having to find 5 volts from something else and have a separate battery eliminator providing the 5 volts to power this, we can power it direct from the battery. And that's a very common way that lots of modern flight controllers do it. They're designed to be powered from usually 2 to 6S. This is a little bit unusual. It goes all the way up to 8S. Now, as I would only ever use this typically in a 3 to 6S plane, that's absolutely fine. So where are we going to connect those things? Because typically, again, those connections that are shown here are usually going to come from some kind of power distribution board, 4-in-1 ESC, that will sit underneath. Looking at the battery connections on here, we can see a couple of likely candidates. There's B+, or VBAT. Those are usually what these kind of things are called. B+ is a big sign. So let's just scroll down and see what the ports do. So we've got ESC port 1 and ESC port 2. On here, that's relating to these 2 connectors. That's here on the flight controller, physically these 2 connectors here. These look like not only do they have the first 4 outputs and then the second 4 outputs, which we're going to need to get hold of, which is very handy. There's also a battery and a ground pin. Now, if we scroll down, we can see that on ESC port 2, the first pin is a battery positive voltage, 2S to 8S, which is normally going to be used for the flight controller to monitor the flight battery voltage, which is great. But also we have a ground as well. By using these 2, we should be able to power the flight controller. Now, luckily with this kit, you get a couple of cables that are designed to plug into these ports. We'll use this second one in a moment when we adapt it for PWM use for servos and things like an ESC. Here's the other cable. And all I've done is I've taken the first wire and the third wire and just twisted them together, because on the computer, as we can see here, the first wire and the third wire should be the 2 that we need to power this flight controller. So I am going to unplug the USB cable and I'm going to plug it into that second connector. So now if I connect these 2 wires to a desktop power supply, set it for 16 volts, which is roughly what a 4S battery is going to be, we can see it all comes on. That's fantastic news. We've now figured out how we're going to actually put this together and how we're going to power it. Now, what this means in practice is that when this is installed in the model, this is going to be connected to somewhere where there is battery power. Usually piggyback it on the XT60 or maybe on the connections from the XT60 into something like the ESC. By having it powered via these 2 cables, the flight controller is going to be powered. However, the kind of voltage and current that's going to be created on the board, on a board like this, is really only made and spec'd to actually power all the components on the board, not to run something like servos, which can be pretty punishing when it comes to current demands, particularly when they're moving large control surfaces or are under stress. So let's look at how we're going to do that next, and also modify this board so that we can plug in things like servos and also a fixed wing ESC. So let's think about how we can connect a load of servos into this flight controller. Now, the 4 outputs for the motors actually come out here. Here on the computer, you can actually see here that they are in this area. So we have the battery and the ground, similar to what we have here that we've already used to power it from this other port. By sheer fluke, there's also the same pins here. However, this is where the motors pins 1, 2, 3 and 4 come together. And that is really what we're interested in, because these are the 4 outputs that we're going to probably have in a plane for something like the throttle, then the 2 elevons if it's a wing, maybe the throttle, aileron, elevator, rudder if it's something like a plane. So these are the connections that we're going to need. However, we also need then to have it powered. Now I'm going to use a trick that I have used in lots of other videos. Now the way it works, if we get a receiver here, this is an old FR Sky X8R, you have all the different channels on here. One of the cables coming in will be from the speed controller, and that's either going to be, I don't know, if your throttle is in channel 1, it's going to plug into there, and that's going to provide the 5 volts and the ground, and those pins are all connected. So as you then plug in the servos and things in your plane, what it actually does is provides the 5 volts and ground for all the servos that you plug in beside it. And I kind of use the same way. Now you could absolutely take something like a servo and you could clip the ends off and try and do some soldering, but I create a little block that actually does that for me. So what I've done is I've made up this little piece here, and what I've done is this is one of those kind of little kind of servo block connectors. These are the kind that normally would be installed on a flight controller that you plugged everything into. And what I've done is I have soldered all of the bottom pins together. Hopefully you can see that. Here's a closer image of it. I've also soldered all of the middle pins together. So now that bottom row is going to be the ground pin. The middle row is going to be the plus 5 volts that's going to come from the ESC when it's plugged in for the throttle. And then the top, the ones that are separate pins, these can actually be connected to the different motor outputs. So the wiring diagram is going to look a little bit like this. So what I need to do is I need to plug in this other cable into this other port here, and here is the battery. This second one here, if we look at the wiring diagram, is going to be R7. Then we have the ground, so we're going to have to connect the ground. That is a wire that we're going to need. That ground wire is going to connect to this bottom row of pins, so we're going to solder that onto there. Then we have a current pin that we're not going to use, and then there's motors or outputs 1, 2, 3, 4, and I'm going to solder them onto these 4 pins. And when that's done, it looks a little bit like this. What I've also done is 3D printed a rear back for this. However, you could just cover it in hot snot, in hot glue, or insulation tape, or some kind of heat shrink to make that all work. And what we've ended up here is a little block that now we can not only plug the speed controller into, that's going to provide the 5 volts for the servos, but also the servos on the plane as well. If, however, we're using an ESC in a model that doesn't produce the 5 volts, then we can wire in a separate 5 volt BEC and plug that in alongside. And that's why I've actually made this one with 5 sets of pins, not 4. So that's an extra one in case the model, when I come to install it, I find that the ESC only has the black and white wire, doesn't have the middle red wire connected, as some of them don't these days. So there you have it. That's how I have done the conversion. The next steps would be pretty standard and kind of where you'd pick up the build in most of the Ardupilot and other series that you've seen on the channel. The other thing that this is also useful for is if you're converting a board to use in something like a car, a rover, a boat, any of those kind of things, this can be handy for, because having that little adapter board means you can just plug the servos in. Obviously, the next step would be to attach the receiver, attach the GPS and compass, and then to start going through the standard setup, calibrate your compass, calibrate the accelerometer, calibrate the radio receiver, set up the modes, do all that stuff. And again, I've covered that in lots of other videos, but I'll probably do another video, again, links to this mini series down below, that will kind of show you how that all works. So hopefully Sarah and those others who have asked, that is how I would convert a quad board into something that could be used in a wing. It's a way to use Ardupilot in particular, using a much cheaper piece of flight controller technology than something like a Pixhawk or a wing board. Thank you for spending your time today watching that video. You can find me in all the usual places on social media, and if you're trying to learn about a subject, then check out the playlist. All of my videos are organized into easy to follow playlists that, if you're trying to learn a topic, will take you from the basics right the way through to some pretty advanced stuff.